Okay, so the next example is similar to the previous example we did with the applications of logs and exponentials. This time the difference is it's going to be a decay, so things are getting over time, something is getting smaller. Growth is when over time things get bigger, obviously. So we have a radioactive substance with a mass of 150 grams. So remember, the units are important. So 150 grams is the beginning. And this decays according to this equation we're given. A equals 150 times times 2 to the power of, now that's actually negative t to the t over 20. That's actually a negative there. A is in grams, so this is important. A is grams. And the amount remaining after t days, so our time is in days. It's not always days, sometimes, like the last example, months, years, seconds, minutes. Find the time taken for the substance to decay to half its original mass. So if we pay attention to the question, originally it was 150 grams. So we want to find out, what we don't know is the time. The thing we don't know is time. Find the time. So that's finding t. So let's have a look at this. We know then half its original mass must be 75 grams because it started off as 150. So after a certain point in time, this A, the mass, what's remaining of the radioactive substance, is 75. So we can say 75 must equal 150 multiplied by 2 to the power of negative t over 20. That's all in the power. So we need to find t. I'll do this all three ways, just like I did before. So the first thing I'm going to do is get rid of this 150 by dividing by 150 on both sides. 75 divided by 150, well, that's a half. So it's a half equals 2 to the power of minus t over 20. Now, this one is interesting because here we have base 2, here we have 2. Remember, that's to the power of 1. So I'd actually could save myself some work. You could take the log of both sides like we did in the previous example, or I could rewrite this so it is 2 to the power of something. It's 1 over, so I know I can use my exponential rule and just write it with a negative power. So 2 to the negative 1 equals 2 to the negative t over 20. Now we have two exponentials equal to each other, therefore the powers must be the same. So I must be able to say minus 1 equals minus t over 20. And now we have a very easy question to answer. So I can just multiply. I might take the negative with the 20. So multiply both sides by negative 20. And I get t equals 20. So going back, t is in days. So it's going to take 20 days for this radioactive substance to halve. Now that was quite easy. We didn't even need to use a calculator. So there are sometimes questions that can be done without a calculator. Of course, we can also, this could also be on a calculator paper. We would always start with the same method. Start with that beginning equation. So you must show your substitution. Very important. So we would start with that. We're going to then graph it, find the point of intersection. So again, it doesn't make sense to have negative values. T is days, you can't have negative days, and A is in grams, we can't have negative grams. So straight away I know my graph is only going to be in the first quadrant. So that can help you. If you need to change your window, that also should help you. And this is A. So if we now go to the calculator, remember you just put y equals 75 in, and y equals 150 times 2 to the power of negative t over 20. We go to our y equals. I'm going to clear that and change it to 75. Then the next one, I can just override it. 150 times 2 to the power. Now, I'm going to use my fraction button again. Alpha y equals, enter. So then it looks exactly like how it's written. So minus x, it doesn't matter if you put the x negative or the 20 negative, or in the middle for that matter. And I want to get rid of that other stuff, so let's delete. Oops, no, didn't mean to delete the whole thing. Let's try again. 150 times 2 to the power of alpha y equals, so it looks like a fraction, negative x over 20. Okay, let's try that. Let's try graphing it. Hopefully I've already got a reasonable screen from the previous question, luckily. So I can see now the graph is going the other way because it's a decay. This is your line y equals 75. Here is your point of intersection. That's what we need to find. So we go second trace. We want intersection, so we choose number 5. First curve, yes. Second curve, yes. And as I said last time, you can have a guess or you can just press enter. It doesn't matter. So we can see x equals 20, y equals 75, which matches what we had here. So again, during this curve, we can see we want to sketch. And this curve actually touches the y-axis. And I'm going to have a line going here. This is the line y equals 75. This is the curve y equals 150. 150 times 2 to the power of negative t over 20. This is of course 75. Now I know I can quickly see what this y-intercept is. That's going to occur when t equals 0. If t is 0 here, you have 0 over 20, which is 0. 2 to the power of 0 is 1. So I have 150 times 1. So I know y-intercept is 150. So you should show important features if you can easily find them. And then, of course, show the points of intersection. So we know it was 2075. And then answer the question. So therefore, of course, you should answer the question here as well. Therefore, it will take 20 days for the substance to halve. And this happens in real life. Radioactive substances, they have what we call a half-life. The substance halves. Okay, remember the other way I did it is also using the calculator, but using the table function. So we go back to the calculator, get out of the graph. Let's go to the table. I've already got my equations in, let's quit that. If I go straight to y equals, I've already got my equations in there. Remember, you don't actually have to have this one, so I could clear it if I liked. You only need this one, really. Go to table, which is second graph. Now I want it to have a half-life. These have got decimals here. And I know what the half-life is, remember. It's because you would still write this. You have to write the 75. And so I want that to be 75. And we can see here it's at 23. That's because I had my table set. So if I go to table set again, maybe I start at 1 this time. Press enter. And then go back to table, second graph. And if I just arrow down, okay, I know that the answer is 20. But what you're looking for is you're looking for it to be 75. Or in this case, because we know the answer, it's an exact answer. Otherwise, you would be looking for it to be as close to 75 as possible. So we can see it's 75 there. So again, you're working out. I just make this screen smaller. Bring this across. Your working out would be, let's get our pen. Different color. Let's use red. We haven't used red. So again, your working out would be the first line, substituting. That's regardless of which method you use. So just substituting what we were given in the question with the half-life. And then you're working out, remember you need 3 entries from your table, x, y. So our answer is 20, so I want 19, 20, 21. I know at 20 that it's exactly 75. At 19, the table tells me 77.645. And at 21, 72.445. Remember, these are not necessary. They may be exact or they may not. The table will round it. And then, of course, you would write the same sentence there, answer the question. Okay, hopefully that is useful. It shows you a few different methods of how you can solve these types of questions. Algebraically, graphically, table. You need to be careful when you can and can't use a calculator. For example, this could be done without a calculator, so then you can't use these two methods. If you can use a calculator, you could use any three methods. So all of them would be helpful if you can use a calculator. All right, good luck with the questions.